All right, everybody, welcome back. We're going to go ahead and get into 1.3 linear functions, slope, and applications. So just a friendly reminder on what slope is. Slope is the rise over the run. We might also see that as the change in the y values divided by the change in the x values. If we have ordered pairs, we'd see that as y2 minus y1 divided by x2 minus x1. And then you can also do y1 minus y2 divided by x1 minus x2. Just make sure you stay consistent on which piece you're pulling from. All right, so we're going to go ahead and graph these three examples and then also determine their slope. So graphing A, we're going to start with that y-intercept. So I'm going to start by going to the y-axis and putting a dot at positive 1. Then I'm going to use that slope, rise over run. So down to right 3. And then I can plot a point, or up 2 and left 3. So just make sure you only use that negative once, either going down and to the right or going up and then to the left, connecting those points with a straight line. And then the slope of that equation is going to be that number in front of x, so negative 2/3 is our slope for A. Graphing B, so x equals negative 2. Well, I'm going to go to the x-axis here and find negative 2 because they're telling me x is negative 2, and I'm going to put a dot. When I see that dot there, it only really makes sense that I could then draw a vertical line because x is always negative 2 no matter what the y value is. So that's just going to be a vertical line at negative 2, and the slope there is undefined. We cannot walk up that wall, so our slope would be undefined. Versus something like this in example C, y equals 5 over 2 or 2.5 if that were a decimal. I'm going to go to the y-axis and put a dot at 2.5. And then I'm going to just go ahead and draw a horizontal line in because y is always 2.5. That's not changing. And then our slope here is 0. I can walk across a straight line. I'm not going up or down at all there. All right, applications of slope. These are just going to be some ideas of when we might be using slope. So if we want to find the grade of a road, grade really means what's the steepness. So is the grade going to be really steep going up or really steep going down? You might see slope when we're talking about a ski slope. Again, that's talking about how steep it is. Or maybe if we're walking on a treadmill, we can talk about the slope if we are going an incline up or down or just walking a flat path. So let's go ahead and look at some word problems here. A curb ramp provides independent access to sidewalks for those who have wheelchairs. Guidelines for the grade of a curb ramp suggest a grade between 5.9% and 8.3%. A federal law states that every vertical rise of 1 foot requires a horizontal run of at least 12 feet. We want to find the grade of the curb ramp shown in the following figure. So they're telling us to find the grade of the curb ramp shown in this diagram. So grade just means find the slope. Remember, slope is rise over run. So when we're looking at this picture, this right here, this 3 inches is my rise running over this 42 inches. So I'm just going to go ahead and write that fraction. 3 inches divided by 42 inches. If we go ahead and simplify that fraction, that's 1/14, which is approximately 7.1%. That falls within these guidelines of 5.9 to 8.3, so we know that that would be a perfect ramp that we could put in. All right, on example number 3, we have an average rate of change. Average rate of change, if we read this entire problem, we want to find the average rate of change from 2008 to 2013. Average rate of change just means slope. So again, we're going to want to find the slope between 2008 and 2013. So if you read through that entire problem, really what we're trying to find is the slope of this red line that's given to us right here. So I'm going to go ahead and write these as ordered pairs. It looks like our x-axis is years. Our y-axis is number of barrels. So when I write these as ordered pairs, I'm going to go ahead and make sure x is the year and y is the barrels. So looking at these two ordered pairs that they were giving us here and here, 2008 is going to be the years, for the barrels being 3,590,000. My second ordered pair has a year of 2013, with the number of barrels being 2,810,000. So we would go ahead and find the slope with these two ordered pairs. So I'm going to ask you guys to go ahead and find that slope, and when we come to class, we'll go ahead and work the rest of this together to go ahead and determine what our slope is going to be. So go ahead and find that one on your own. When we come back, we'll finish it. All right, moving on. Finding the slope in the y-intercept of the following equations. All right, this one is in slope-intercept form, y equals mx plus b. So our slope is just going to be the number in front of x, negative 0.25. Our y-intercept is that b value, or that number that is not touching x. So I'm going to write this as an ordered pair. 0, negative 3.8. Example B, again, this one is already in y equals mx plus b form. So slope on this one is the number in front of x. If the number is not written, then that slope is just 1. The y-intercept written as an ordered pair, 0, 4. And then go ahead and try C. See what you get, and then again, we'll do that one in class. And I'm going to save example 5 for us to talk about in class as well. Thanks for watching.